We on YouTube.
So I can't copy and paste in VMware. Is that normal? Or
Sorry, say again?
I was not able to copy and paste in VMware, the pink area.
Yeah, because because that's a console. It's not actually a terminal.
Okay.
If you want to copy and paste, use PuTTY.
Okay.
Yeah, you can definitely copy and paste in PuTTY.
Okay, and it gave me a few. I don't remember what the errors were, but it gave me a few errors when I hit the install command.
It's aptitude install.
Yeah.
What kind of error?
I really don't remember.
Okay, you have to tell me what error you're getting in order for me to understand.
Okay, I'll look it up and send you an email.
Okay. All right, sounds good. All right. So homework assignment. New homework
Yeah, I know. I
assignment
saw
is
that the other day.
called. It's called binary add. So it really is a simple homework assignment, but I'm pretty
they're
proud of it
VMware
because I made a spreadsheet
Yeah.
that can do
Oh.
binary number conversion.
Oh yeah.
Using spreadsheet
I know
functions.
the
Now you need to
software
know.
that's the
So let's go ahead and take a look at that homework assignment. So it's called binary add. So okay, we got one submission already. Very good. It's due next Tuesday on the 12th. So you do have quite a few days to do it. Most of you who actually understand the material from the lecture, or you actually understand that stuff here from 440, can probably do this one in 5 minutes. Okay, and the biggest overhead will be downloading the file and uploading it again. The actual part of the homework assignment should not take too long. Some of you may feel that this is a challenge and you want to use a spreadsheet function and have your own formula to do it for you. Be my guest, okay? I don't have any objection as long as it is your own work, okay? If you're not copying from somebody else, you're trying to figure out exactly how to use your own formula to calculate, the individual bits. Be my guest, because that actually helps you understand the material even more than doing it by hand. So let's go ahead and take a look at the homework assignment, and we'll follow the instructions right here. Right-click here and download the file. Do not click, meaning left-click, to open it from the link, because otherwise it will be read-only. So you right-click here, and then you save link as, depending on which browser you get, it's a different setting. So you save it, and after you save it, you can open it with any software. You can use LibreOffice, you can use OpenOffice, you can even use Microsoft Office 2007, but you have to make sure that yours is updated, because earlier ones are not compatible with open document format. So this is the document that you will see when you open it. I'll zoom in a little bit here. So your job is to change these two particular cells first. This one, which is B1, cell B1, you have to use the least significant digit of your student ID, which means it's the rightmost digit. Okay, so I hope most of you know what your student ID is. So let's say this is a really cool part. Okay. So let me change this number to, let's say, 5, okay? If I change it to 5, you can see the ASCII code changes automatically, and also the bit pattern here changes as well. Now, if you look at this bit pattern here, each one is a formula to try to figure out whether it should be a 0 or 1 for a particular bit of that number. So I'm pretty proud of making this all work using a spreadsheet.
Yeah.
Yeah.
I would be.
And then the same thing with the other one. The next one is the first letter of your first name. So with me it is T, but let's change it to something else. So I'll change it to B. Okay. So with B, uppercase B, the ASCII code is 66, and this is 66 in binary. It's pretty clear that this is actually correct, because 66 is 64 plus 2. This is a 1 followed by 6 zeros, which is 64, because it's 2 to the power of 6. And this one is a 2, because it is 1 with a 0 following it, so it's 2. Okay, so your job is to fill in the part that is highlighted in kind of like a pale yellow color. That's all. Okay. In other words, you have to understand what a half adder would do, and you have to figure out how to make the carry of the next column work based on what you have on a particular column. Are there any questions about this? No questions? If anyone gives me just the last row here, that person will not get any credit. Unfortunately, Moodle does not let me put in negative scores. Okay? Because it's easy to get to the last row, you can always use your calculator to do base conversion to double check that your last row is correct. But what I'm really trying to focus on are these two particular rows. Okay, the result of half adder, the result of carries, and this will be the result of another half adder. Okay, are there any questions about this homework assignment? No questions? It's all okay? So that's your homework assignment. If you want to find out exactly how to use a formula to calculate each bit value, be my guest. I think that's actually a very good exercise. It's not that hard. It really is not that hard. Yep.
So we're just turning that in literally the spreadsheet. But
that is correct. Yep. So let's say I'm done here. Okay, so I save the file. And after you save the file, it probably is a good idea to close it first, just so that you make sure that your file is finalized. You go back to the homework assignment. Now let me change my role to a student, otherwise you cannot see what you should be seeing. So let's see here. Switch role to student. All right, so as a student, you will see this button here at the end of the assignment. So click that button, and you will see an upload interface. You can drag or drop. I just click add here, go to the folder, which typically will be in your download folder. So I go to my user account, download, and here's my binary add. Click open, click upload, wait a little bit, and then click save changes. Don't forget to click save changes. And when you're all done, you should see something like this. It will tell you what was your last modification time and when it is due, and a link to download the file back, just in case you want to find out what you uploaded. Okay? Are there any questions about the entire process of turning in this particular homework assignment? No questions? All right. How about the other one? How about the one where you have to install the tools and go through an example of how to assemble, link, and run and debug your assembly language program? Are there any questions about that one? No? Okay. And remember, PWD is in back quotes, not forward quotes. Okay. All right. So we are all done with both homework assignments. Neither of the homework assignment is supposed to be really difficult, or it really should not take a long time. I save all the good stuff for later. Now we're back to memory access, and we are close to getting this part done already, so that's good. All right, so we are moving on to section 5, which talks about accessing input-output devices. And by the way, I also looked up what is GDDR5, the standard of GDDR5. It looks like they're really just stacking up additional features on top of the basic DDR concept, which means they're transferring bytes in burst mode, so they don't have to latch on the address again and again and again, because they're all sequential numbers. But with each revision, they just add additional features, increasing the width, for one thing, and also you're changing the signaling specification, lowering the core voltage, that sort of thing. But the number does not always indicate, how fast it is. So it's not always, GDDR5 is twice as fast as GDDR4, which only existed for a very short amount of time. All right. So getting back to accessing I/O. Now everything that we have talked about so far has to do with the memory bus. Now the memory bus, as the name implies, can only interface with memory. If you have a super duper processor, lots of RAM, like 16 gig, but no I/O devices, how useful is that computer?
Useless.
It is as useful as a space heater. It's not useless. You can still heat up the room using it. Okay? Especially when you have a Pentium 4 processor. Okay, so why is that? Why do you need input-output in order to make a computer useful? Any computer, doesn't matter which one.
Interact.
To interact, exactly. So you need to be able to get some sort of input into the computer, and then your program will do some processing. But after the processing, it has to do something, to the output in order for the computer to be useful, right? Okay. Now this applies to just about any computer that we encounter on a daily basis. Your cell phone is filled with input and output devices. The touch screen is an input device. The accelerometer is an input device. Yes, Darren.
I got a name. It is someone from your class. I hope I don't mispronounce.
We have a winner. All right.
That's yours. There you go.
Thank you.
You're welcome.
Cool. Okay. So your cell phone has a lot of input devices. The microphone is an input device. Let's see. The GPS is an input device.
The USB. USB.
USB is input-output. You can actually use it in both direction.
Camera.
The camera is an input device, and in fact, most phones now have 2 cameras. On most Samsung cell phones, they also have a proximity sensor, so they can detect whether you're holding it up like this or whether you're holding it like this. So all of those are input devices. Output devices, the screen itself is definitely an output device. The speaker is an output device. The radio, the Wi-Fi, and also the 4G radio is input-output. Okay, you use it for both purposes. But basically, with a tiny little device like this, it's already filled with both input and output devices. A regular computer has all sorts of input-output devices too. It's actually less. Okay, if you think about a desktop computer, it doesn't even have as nearly as many devices as a cell phone or a tablet. What about the anti-lock brake control system that your car has? It has an input device. The input device actually has input devices because it has to monitor the pedal position of your brake. It has to monitor the rotational speed of your wheels. So those are the minimum input devices. The output would be to control the caliper, to control the valve, of the hydraulic valve of the calipers. So that's the output of an anti-lock brake system. It's not something that we can see or touch, but it's definitely there as well. So all computers need some kind of input and output. So the question now is, how does a processor interact with these input-output devices? That's the question. There are 2 basic mechanisms to do that. We'll talk about this one first because we already talked about how to interface with memory. How do you write to a memory location, and how do you read from a memory location? This is one particular way to do it. It's called memory mapped I/O, which, as the name implies, means that certain locations in memory are not actually memory locations. Okay, when you write to those particular locations, you're actually writing to the input or the output of a hardware input-output device. We call those, input-output registers. Just for the name, those are called registers, which has nothing to do with the registers that we'll deal with later in programming. Okay. So if I'm just going to read my text here, this is not used by Intel processors. It's typically used by Motorola processors. Certain regions of memory is reserved, and these regions of memory do not map to memory chips, but to I/O chips, input-output chips. The region of memory mapped to I/O can be hardwired.